Good afternoon. We're presenting Monte Carlo simulation support in LunaSim, a browser-based system dynamics modeling platform for sensitivity analysis by Akash Saran, Arjun Majumdar, Ryan Chung, Caleb Wen, Ishan Ketterfall, and Marcus Stebb of Poolesville High School. LunaSim is a free open-source system dynamics platform that runs entirely in a standard web browser created by students at Poolesville High School. System dynamics models depend on parameters such as growth rates, decay constants, and initial conditions, which in most real-world applications are estimated from noisy data rather than known with certainty. Running a model with a single fixed estimate produces just one trajectory, one that can look precise while representing only one of many plausible outcomes, which obscures the system's true range of behavior when that estimate is off. This is especially consequential in fields like public health epidemiology, ecological modeling, and systems engineering, where the full envelope of possible outcomes can matter as much as the most likely one. Monte Carlo simulation addresses this by running an ensemble of simulations, sampling uncertain parameters from specified distributions, and aggregating the results into confidence bands rather than a single line. The tools that support this well typically require a desktop installation and commercial license, limiting their use in classrooms. Meanwhile, free browser-based platforms, including LunaSim, prior to this work, had no Monte Carlo capability at all. This defines a problem we address, the absence of a free browser-based platform for probabilistic system dynamics modeling.
Now let's talk about how we brought probabilistic analysis directly into the browser. The core of this work is Monte Carlo simulation support, something that previously required commercial desktop tools. With LunaSim, users can now assign probability distributions to individual models and run large ensembles of simulations in parallel using the Web Worker API. Instead of getting single deterministic outcomes, you'll get a range of plausible system behaviors. Once all the runs complete, the engine aggregates the results and computes percentiles at every time step and renders them as confidence bands directly under the chart. This allows you to see each confidence band as a shaded region, showing the probabilistic spread of outcomes with the median tracked down to the middle. Users can configure a 90, 95, or 99% probability distribution, or create a combined display and switch between tracked variables all without leaving the tab. The second major piece is the live API integration. We added a bracketed syntax that lets users pull real-time weather, macroeconomic, and financial market data directly into their model equations. This means that your Monte Carlo runs aren't just sampling from an arbitrary hypothetical range, but can be seeded with actual current conditions. For example, a portfolio model can vary its return rate around a live stock price. Together, these features mean that LunaSim can produce confidence bands that are both statistically rigorous and grounded in what's actually happening in the real world right now, all for free in any browser.
Now let's look at what the results actually showed. The two charts you're looking at here represent the core of what Monte Carlo simulation adds to LunaSim. Each one is a confidence band, a shaded region showing the full range of plausible system behaviors across hundreds of simulation runs, with a median tracked right down the middle. Chart on the left is a supply chain model. The band starts at zero spread because every run begins from the same initial conditions. As time advances and the sample transit times start diverging, the band fans outward. By t equals 7.5, the outer 90% band spans a range of roughly 180 units, and you can see the asymmetry in the shading. It's wider below the median than above, which directly reflects the shape of the distribution we assigned. The chart on the right is an investment portfolio model that pulls live equity prices from the FinHub API at runtime. The annual return rate and withdrawal rate are both sampled from distributions, so the confidence band is grounded in actual current market conditions, rather than arbitrary hypothetical ranges. That's what makes this different from a standard sensitivity analysis. Both charts are produced by the same Monte Carlo engine running parallel simulation ensembles using the Web Worker API. At 1,000 runs, parallelization cut execution time by 68.5% compared to running sequentially. That reduction is what makes this scale of probabilistic analysis practical inside a browser. You don't need any desktop software installation at all to achieve this.
So, to conclude, we've shown how LunaSim brings probabilistic system dynamics modeling into a free, browser-based platform that's easy to use for classrooms, research, and various collaborative projects. Instead of only seeing one possible outcome, users can run Monte Carlo simulations and visualize confidence bands, which give them a better understanding of how uncertainty affects a system over time. And by making these tools available directly within the browser, we hope to make advanced system dynamics modeling more accessible without requiring specialized software or expensive licenses. We also introduced live API integration, which allows for these models to use current weather or financial market data instead of relying on fixed hypothetical values. And this makes it possible for simulations to better reflect the real world while still allowing users to explore uncertainty through Monte Carlo analysis. And looking ahead, one area we really want to explore is so-called correlated parameter sampling, and this is where related variables can change together and better represent real-world systems. And we also plan to expand our live API support by adding more data sources, such as population and census data, or maybe even transportation and traffic data. And this would allow LunaSim to support an even wider range of modeling applications. And overall, we hope these additions make probabilistic system dynamics modeling more accessible while keeping LunaSim simple, free, and completely browser-based.